A logical statement is a statement that can be labeled true or false. So for example, I can pass an exam is a logical statement, and the three connectives you're already familiar with, which connect Boolean expressions, are and, or, not. And you've seen the truth tables for these. So the logic symbol for and is an upside down V. And in Boolean, this had the dot symbol. And this is the logic symbol for or, which was plus in Boolean. And in logic, not is a tilde, which was the complement in Boolean. And in Boolean, we had a 1 for true and a 0 for false. So the truth table in logic is equivalent to an IO table in Boolean. Now compound statements are equivalent if they have the same truth values for any set of truth values. So an example is De Morgan's law, being not x or y is equivalent to not x and not y. So these two expressions have the same truth values for all permutations of the inputs x and y. And this is also true for De Morgan's second law. Now a tautology is a statement that's always true. So it has all trues in the truth table. And the opposite of a tautology is a contradiction. Now another important connective is implication. So here we have x implies y, which is the same thing as if x, then y. So you can look at this as x being the assumption or hypothesis, and y being the conclusion. So for example, if you consider the statement x implies y, being if it's Monday, then I study. So if we look at this truth table, we have if it's not Monday, then I don't study. So in this case, x implies y, because we're basically saying the same thing. So this is true. Now if it's not Monday, then I study, then this can also be true, because I can choose to study even if it's not Monday. Now if it's Monday, then I do not study, then that contradicts this statement. So in this case, x does not imply y. And here we have if it's Monday, then I study, so this statement is true. Now the converse of this statement is y implies x. So that would be if I study, then it's Monday. So we read this backwards. And the contrapositive is not y implies not x. So for example, if I do not study, then it's not Monday, is the contrapositive of this statement. And the inverse is not x implies not y. So if it's not Monday, then I do not study, being an example. So in other words, the inverse is the converse of the contrapositive. So from this truth table, we can deduce that not x implies y, being equivalent to x and not y. So try to actually verify this using a truth table. And therefore x implies y is equivalent to not x and not y, which is equivalent to not x or y. So here we applied De Morgan's law. And also note that not x is equivalent to x.